All right, this will be our second video in the first unit, and that unit is Introduction to Industrial Hygiene. In the first video, I gave you some very basic introductory information. Hopefully it's helping you to get a better understanding of what industrial hygiene is all about and how it's different perhaps from other safety management. It's a lot about chemical exposure in the workplace. It's about the environmental conditions in the workplace that can have adverse effects on the workers. One last thing I want to do, and hopefully this will be a shorter video. I'm not going to go into a lot of great detail with this, but I want to talk about what industrial hygienists call the evaluation process. It's really a hazard analysis process, but it focuses more on environmental hazards in the workplace, as indicated here. An evaluation of environmental hazards in the workplace. There is a chapter in your textbook, chapter 15. The title of that chapter is Evaluation, and it's about this process that we're talking about. A lot of the steps that I'm going to outline just very briefly are discussed in more detail in chapter 15. You're not required to look at chapter 15. I don't even cover chapter 15 in the second industrial hygiene class, but I think it's some good information to look at, especially if you're leaning more toward industrial hygiene, maybe as a specialty, or maybe if you go into one of those industries with more industrial hygiene types of hazard exposure. If you work in a chemical facility or a facility that uses a lot of highly hazardous chemicals, it may be valuable. I mean, information in general is valuable. The more we know, the better we are. But for me, what we're really doing with this evaluation process is a hazard analysis. And if you're not familiar with the term hazard analysis, all goes back to Military Standard 882 and system safety. It's a process for identifying hazards in the workplace which could cause harm. Identifying conditions, hazards in the workplace which could cause harm, injury, property damage, and so on. And that's really a simplified definition of hazard analysis, but that is a lot of what we do as safety managers. That's a lot of the critical thinking that we do in our jobs, is what could hurt someone. And the next step is, once we identify what could cause problems, how can we prevent? How can we control? How can we control that hazard? How can we control those conditions? How can we eliminate those conditions? We can implement engineering controls, administrative controls. If we can't, if we don't have anything else that we can do, we can implement personal protective equipment controls. But again, let's take a look at this evaluation process, and it's a process for analyzing environmental hazards in the workplace. Multiple steps I'm going to outline here. These are not necessarily in sequence. They may occur simultaneously. They may occur a little bit out of order. I'm always leery about a step 1, step 2, step 3 process, because rarely does it ever work out perfectly. Well, you do step 1 first, then it's step 2, and then it's step 3. It's usually not that simple. Even though I'm calling it steps, and you're going to see step 1 and step 2 in some of my slides, it most of the time doesn't work out so nicely that it's going to be in perfect sequence in chronological order. One of the things we need to do when we're evaluating a workplace is look at the literature. Look at any applicable research or any applicable writings that are out there. We can learn so much just from reading. The library is an important tool, and the internet, sad to say, but the internet is kind of becoming the modern library. There's a lot of useful information at our disposal through the internet. Information that's applicable when we're evaluating hazards in a workplace, when we're looking at industrial hygiene types of hazards in a workplace. Now, I'm combining review of literature, benchmarking, and consultation together, but they're really different processes. Review of the literature, that's let's find out what's been written about this operation, this problem that we're evaluating, this workplace that we're evaluating, and see what we can learn from that. Benchmarking is when we look at other companies. Maybe other companies are focused or are facing the same types of work environments that we're facing. One of the easiest and most effective things we can do as safety managers is get on the phone and call our buddy that works over at a similar company. What are you guys doing? What have you learned about this particular hazard, this particular operation? Learn from their experiences. And that's, strictly speaking, that's not benchmarking, but it's kind of benchmarking. Another thing we can do is seek outside consultation. If you're a safety management generalist, meaning you're not an industrial hygiene specialist, there are going to be those occurrences where the best thing you can do is call in an IH specialist as a consultant. I wouldn't call in another generalist. There are a lot of consulting firms out there that are generalists, that really aren't IH specialists. Don't call those. Don't call those consultants. Call consultants that are industrial hygiene specialists. The individual that comes out to help you with your evaluation should be a certified industrial hygienist, in my opinion. If I'm going to spend the money on an industrial hygiene consultation, I'm going to bring in a CIH to help me with that evaluation process. Take an inventory of substances in your workplace, chemicals that are used in your work processes, or other harmful agents that could cause work-related illness. That's going to be an important part of this evaluation process of identifying hazards, understanding the potential dangers, and as we go through this process of identifying the dangers, we're going to at some point come up with controls to control those. Oh, and let me go back to this. Speaking of controls, when we call our buddy over at another company that's very similar to the company we're working for, they've already gone through this process. We can ask them about controls. Maybe the other company installed a ventilation system. We can pick their brain on how that went, mistakes they made, or things that went well for them, victories they had, and learn from those experiences. Yet, never be too proud to ask other people for help. I still do it to this day. If I'm working with a company that's having issues with a crane and I don't know the answer, I've got several people that I can call that will have the answer. A lot of times I call crane operators because they might know more than the crane experts in many instances. I'll call my crane experts also, but crane operators are a real good source there. But we can learn about hazards, we can learn about controls through the literature, benchmarking, and consultation. An inventory of substances. What substances are we dealing with? We need to get a good idea of the process that's involved in this operation. What is the operation? What are the steps involved in the operation? What are the different tools that are involved in the operation? There's a lot of different terms we can use for what we're doing here. We can come up with a process flow diagram or flow sheet. I like the term work plan. What we're doing is a work plan. The operation, again, all the different components of that operation, and this generally is going to be a step-by-step. Step 1, you do this. Step 2, you do that. Step 3, you do that. After you have that work plan, after you have a pretty good handle on the process, and you know what chemicals are going to be involved, then you're in a better position to identify the hazards that need to be controlled. And then this is all built upon the benchmarking you've done, the review of the literature you've done. You're at this point, if you've done this, you have a really good chance of coming up with a quality evaluation of the workplace. and we're talking about evaluation of industrial hygiene types of hazards. A field survey. Yeah, this is kind of goes along with the process flow sheet, but what is the work environment like? And I'll go into more detail here when I get into an example here in a moment. Monitoring and sampling. We're monitoring for exposures in the workplace. What are the concentrations of potentially harmful substances or harmful substances in the workplace? We can use direct reading instruments. We might have to use a sampling procedure that would involve sending samples to a laboratory, but we're monitoring the work that's taking place and the presence of these substances in the workplace. Are they at a dangerous level? That's what we're wanting to get at with our monitoring and sampling. Are the concentrations of harmful chemicals, harmful substances at a dangerous level in our workplace? If they are, we got to do something about it. Engineering controls, administrative controls, maybe as a last resort PPE controls. But we always want to go with an engineering control, that highest order, highest level, most effective control when we can. And that leads me to this point here. Controls, corrective actions if needed. Again, engineering controls, work practice controls, or administrative controls. These terms are, I'm not going to write that out, administrative controls, work practice controls. To me, they're not the same, but they're often used interchangeably. To me, a work practice control is a type of administrative control. And if you haven't seen the hierarchy of controls, I covered in my other online class that's going on right now, so I'm not going to go into a lot of detail here. If you haven't seen this before and you have questions, what do you mean by engineering control? What do you mean by administrative work practice? What do you mean by personal protective equipment control? Get on the internet, get on the email, text me. We can talk about it. We can do a Zoom conference and talk more about it. Or you can watch one of my other videos that talks about hierarchy of controls. And here's this reference to chapter 15 again that goes through this process, talks about these same steps that I'm outlining here, these same phases that I'm outlining here. Not required, but you might benefit from taking a look at chapter 15. But let's go into a little more detail, and let me give you some more examples of what we can gain by engaging in these different processes, the review of the literature, for example. But I want to give you examples within the context of it's not real world, but it's kind of a real world. It's a make-up real world example that we're using here. Let's say we work for a ship manufacturing company. They manufacture ships, and they are expanding their operations. The expansion involves painting and or powder coating all metal and wood components in-house. Before this expansion, the company would do all the fabrication work, but they outsourced all the painting and powder coating to a subcontractor. Now they're bringing it all in-house. They're wanting to do it all themselves. They're going to do the fabrication. They're going to do the assembly. They're going to do the painting and the powder coating themselves. When they take on the painting and the powder coating, they're taking on a lot of hazardous substance exposure. They need to know what they're getting themselves into before this operation commences. And this is one of these kind of scenarios where the evaluation process is essential. If your company is developing a new operation, if you're expanding operations, if you're doing something differently, you need to consider what chemicals are involved. What are the exposures likely to be for workers? What controls do we need? Now, this is just one particular example of where the evaluation process can be applied. It doesn't have to be a new operation. It could be an existing operation that we want to evaluate. A lot of the same steps are involved. Literature review, inventory, process flow, work plan, and so on are going to be applicable whether it's a new operation or an existing operation that we're evaluating. But this is our scenario here. The company needs to do this evaluation to ensure a safe work environment for these painters and these people who are going to be exposed to the work of the painters, because it might not be just the painters who are exposed to the dangers. It could be other workers as well. So first thing I'm going to do, if I'm the safety manager in this type of situation, I'm going to do some reading. I want to see if there are any OSHA pamphlets, industry training material, manufacturer recommendations that have been written. I'm gonna scour the earth for anything I can find about this process. I'm gonna read all I can about painting and powder coating, and not just any painting, but painting inside of a closed environment, because that's what we're going to be working with here. They're not going to be painting these components out in open air. They're going to be painting inside of a structure that right out of the gate we know it's probably going to need some enhancements to the ventilation system, because it is an enclosed space. Maybe there needs to be other equipment involved in the process, not just for safety but for quality purposes. Maybe there needs to be spray booths involved. Yeah, but I want to do my reading. I want to read all I can. I want to encourage other people involved in the process to do their homework as well before you just dive into this operation. And I just thought of something. It reminds me of the first company I worked for. They got it in their head that instead of hiring truckers to move materials and equipment, we're going to do our own trucking in-house. My goodness, talk about the liability. Talk about the exposures. Talk about all the I's that have to be dotted and the T's that have to be crossed. That was an enormous undertaking. I was able to slow the owner down and say, oh, that's a great idea, but here's some things we need to think about here. We got all these DOT regulations that we're going to have to be compliant with. We're going to have to be checking logbooks, and we're going to have to make sure that we're following all the requirements when we hire a driver. There's so much to do that he hadn't thought about. He just thought to go out and buy some trucks and hire some drivers and they're good to go. But there's so many different things that have to be considered. And I knew about a lot of those things because of some reading I did. I wasn't any DOT expert, but I knew he was wanting to do this, so I did some reading and learned what our exposures would be, what our compliance issues would be, and went from there. But if it's painting or whatever you're doing, going into the trucking business, there are things to learn before you start executing that operation, and we get a lot of that through reading. Now, OSHA pamphlets can be a great source, and it just so happens that there is an OSHA fact sheet, hazards associated with spray painting in shipyards. Pull that up here. It's not a lot, but it gives you a good head start if you are dealing with this kind of work operation. It talks about exposure to hazardous substances, fires or explosions. Paints are flammable. Most paints are flammable, and that has to be taken into consideration. We have to have controls in place to keep the concentration of paint in the air outside of that flammability range. We don't want a concentration that's going to be within that flammability range that's could be ignited if a spark is introduced, for example. How do we keep the concentration outside of that flammability range? Ventilation. We use ventilation to keep the concentration down beneath the flammability range. But anyhow, this is just a quick example here. I don't want to spend too much time on that. But those are the kinds of resources that you can that you can find that are easily found. That's going to help you identify hazards, the harm that could happen, all the bad stuff that could happen, and control methods as well. That fact sheet talked about control measures that should be considered by companies that are engaging in this type of operation. And I'm calling literature review step 1. Step 1B, whoops, I just hit that again, sorry. Calling literature review step 1. Step 1B is making some calls. That's the benchmarking, talking to a consultant perhaps. What are other companies doing? Maybe you contact another company. Doesn't even have to be in the bridge manufacturing business. Maybe they manufacture tractors, but they do their own painting and powder coating. Contact them and learn from their mistakes and their successes. That can be so valuable. And if you're talking to the safety person for this other company, safety people love to share with each other. I think people who end up in safety who just naturally like to help other people. So if I call George over at the tractor manufacturer place, George is probably going to tell me that, hey, we tried this ventilation system and it just did not work for us. You need to consider this other one. He might tell you that they tried the ventilation system, it didn't work, they brought in another system, or they brought in another ventilation specialist that corrected the problems. Or he might be able to tell you about cooling technology that they had great success with to keep their workers cool. They used vortex tube cooling systems to keep their painters cool when their painters were inside the spray booths or whatever. But you can learn from other safety managers, other companies. If you need to, contact a consultant or a specialist. I might contact a specialist, industrial hygienist who has a lot of experience working with companies who do their own in-house painting and powder coating. That's could very well be money well spent. Now, if your company doesn't have the budget to hire a consultant, your insurance company may have industrial hygienists on staff, and their job is to help clients. I know when I did my silica sampling back in 2015, we didn't have the equipment, and my company wasn't going to buy all the equipment, all the cyclones and personal sampling pumps and everything that I needed to do that. So I talked with my loss prevention specialist for my insurance company, and he set me up with an industrial hygienist for my insurance company. The industrial hygienist came down, brought the equipment, taught me and all the other safety staff how to use that equipment, and helped us through the process of taking silica samples on the job site. Once we had our silica samples, we sent the samples to the insurance company's laboratory. The company was Travelers. I think I can go ahead and mention that. It was a great company from that standpoint as far as providing resources to us. So if you work for a company, your boss won't hire an industrial hygienist consultant to come in, maybe your insurance company can help you out, because they have, in many cases, the larger companies will have industrial hygienists who can help with the process. But if you do need to hire someone, if you do need to fork over the cash, it could be worth the money. And it may even be worth the money to bring them in multiple times, if that is necessary, to make sure all the I's are dotted and the T's are crossed. You want to make sure it's done right. One thing, just my quick look at some of the painting literature, hazards, potential for harm, fire, explosions, harmful effects from toxins in the paint, and also the high temperatures in work areas. Again, these are likely to be enclosed spaces that need to be ventilated, that may be subject to high temperatures. So as far as controls, ventilation equipment, and that's where we might bring in another consultant. Bring in a ventilation specialist, an engineer that specializes in ventilation systems. Also might be money well spent. We could, in terms of our ventilation system, we may need some type of exhaust ventilation system to remove the paint spray residue. We may need a combination of general dilution exhaust ventilation to help maintain that safe temperature and to keep the concentration at a level that is safe for workers. And we have to consider the LEL. We need to keep that LEL below 10%, based upon the literature that I looked at just very quickly for this illustration. Hopefully not, but we may need to provide respirators. If our ventilation system is working well, with painting though, you may need respirators in addition to properly functioning ventilation equipment. So again, that's going to be based upon the exposure level, the concentrations in the work areas. Our ventilation equipment may not be adequate. We may need to provide respirators. We may need to have a respiratory protection program in place also, which that's a whole other topic there, respiratory protection program. And that's something we get into more in the second industrial hygiene class. Look at my time here. I'm not doing too bad, 28 minutes or so. And one option, and I was talking to one of our graduates here a while back. They have employees working in a foundry environment where it's really hot, and I mentioned personal cooling equipment to them, vortex tube suits. They had never heard of that. The vortex tube technology is an amazing technology. That vortex tube device can be mounted inside of a full body coverall or full body suit. That vortex tube device is connected to an air compressor, and it can lower temperatures 20, 30, 40 degrees. It's like a personal air conditioner. The downside of it is the worker is tethered to an air compressor, but in a paint booth, paint room environment, that may not be a bad deal. It may be workable. There are some operations where you can't have workers tethered to a hose. It makes it really hard for them to do their jobs. But that would be an example of a control device that could be implemented to keep workers comfortable, but more importantly, keep them protected from developing a heat-related illness. Moving on. Materials inventory. And with paint operations, we're going to have paints and solvents, paint removers, thinners, cleaners. For anything in our inventory, we got to have the SDS for those materials. In that SDS, we're going to look for potentially harmful components, the effects. All that information is going to be in the SDS. We're going to look at exposure limits, which we really haven't talked about yet, which I will in just a second. But there's a lot of information in the SDS sheet that we can look at. Here's an SDS right here for paint thinner. Let's go ahead and take a look at this. Whoops, that page can't be found. That did not work. Let's try the SDS for aerosol paints. When you're making a presentation, always check your links in advance. And I usually do, but I didn't check that. I checked aerosol paints because I know it's here because I checked it, but I didn't check the paint thinner. But here's an example of what we're talking about with the safety data sheet. All sorts of information. And I'm not going to go through all the different types of information here because I'm going to have you do that in one of our assignments or one of your assignments. I'm going to give you an SDS sheet to look at, and I'll just leave it at that for right now. Now, the SDS sheets are not only good information, they're required by law, and I'm going to get to that here in just a second. Now, on the issue of exposure limits, the exposure limits are not always found in the SDS. You may have to look at other resources. You may have to look at the NIOSH Quick Guide, that NIOSH resource that I mentioned in the first video, or other sources to find the exposure limits. Table Z in the OSHA regulations would likely have the PEL exposure limit, the permissible exposure limits, in Table Z for whatever substance it is we're looking at. SDS it's pretty common that they do, but they don't always have exposure limit information. And here's what we mean by an exposure limit. We're going to get into this in more detail in the next couple of units. I'm probably going to drive you crazy talking about exposure limits, the TLBs, the PELs, the STELs, the RELs, all the different types of exposure limits there are out there. But the exposure limit, what we're talking about here very simply, is a concentration value. The parts per million or other measures that might be used. But it's a concentration value. It's a threshold. Above this value, there is danger to the workers. Exposure levels or concentrations below this value is generally considered safe for workers. And I will expand upon that and some of the caveats that go along with that when we talk in more detail about the exposure limits. Because it's a big part of industrial hygiene. It's a big part of safety management. Understanding exposure limits and being cognizant, aware of the exposure limits when our workers are exposed to hazardous materials, hazardous substances. One common exposure limit that I had to always be aware of in the construction industry, because we had we had internal combustion engines running, producing carbon monoxide, and sometimes they were in not confined spaces, but areas where there wasn't really good ventilation, natural airflow. So I was always cognizant, aware of the carbon monoxide concentration. Our workers wore sniffers that would continually measure the carbon monoxide level in their work area. But the permissible exposure limit, which is the OSHA exposure limit, and that's all I'll say now. I could do 30 minutes just on the difference between the PEL and the STEL and the TLV and so on. But permissible exposure limit for carbon monoxide is 50 parts per million, and that's a 8-hour time weighted average. The permissible exposure limit is 50 parts per million. And we're going to talk about time weighted average, exposure limits, and all of that stuff that I just blew past you very quickly. But for now, exposure limit is a threshold value. Above that concentration level, dangerous. Below that concentration level, workers should be good. But there are some caveats to that we'll talk about later. But back to SDS sheets. I said that it's not just a good source of information, it's required by law. OSHA requires employers to provide safety data sheet information to all workers exposed to substances. It's not optional. And it is one of the most commonly cited violations. OSHA will go into a workplace and they'll notice that, hey, there's some chemicals over here. They'll ask whoever is guiding them through the inspection process, guiding them through the tour of the facility, can I see your SDS sheet for XYZ chemical? And if the company is not able to provide that SDS sheet almost immediately, they need to be able to provide it immediately, because it needs to be available, so if a worker comes up and asks for it, it would be available. If they can't do that, that's pretty much a slam dunk citation for the OSHA compliance officer. So SDS sheets are a big deal. For me, SDS sheets are a big deal not because of OSHA. They're a big deal because of the valuable information they contain. Now, the regulations that I'm referring to are part of OSHA's Hazard Communication Standard, and it's found 1910-1200. And I'll go ahead and click on this link here. And let me buzz this out if I can. There we go. Fit everything into the recording window. But this is 1910-1200. All the regulations that companies have to comply with when it comes to the hazard communication standard. Supplying the SDSs, making them available to workers is important part of that compliance. And it used to be years ago that the way a company would comply, they'd have these big 3-ring binders full of all these paper SDSs. And I know the first company I worked with, we had 2 big 3-ring binders, 3-inch 3-ring binders, and each superintendent had to keep 2 of those 3-ring binders in his truck because of all the SDSs we had. We had to have those SDSs because we had the chemicals, the products that went along with those SDSs on our job sites. We had curing compound, we had form release oil, we had WD-40, we had different types of greases and lubricants, and you have to have an SDS sheet for all of those things. So the books could get big. That was the old days. Nowadays, we're using digital technology. Companies are able to maintain their database of SDS sheets on a server, and they're able to give the employees a link that they can use to go to that database and find the SDS sheet that they want. But the way it needs to be set up, it needs to be available to employees, whether it's in a 3-ring binder or using digital technology. If a worker wants to know, if he wants information about XYZ product used in his factory, the employer needs to provide that. That's the requirement. Employees have the right to know the dangers associated with the materials they're using. So that's a quick hit on SDS sheets and the hazard communication standard. In your career, you will probably take a half day or a full day workshop on the hazard communication standard. Oh, and one other thing I need to mention. There are some changes in the works for the hazard communication standard. It was last updated in 2012, and I won't go into all those updates and the globally harmonized standard and all that, but it was last updated in 2012. Here it is 2022, and we're looking at some more changes that are going to be occurring. So just something to look forward to. There's always changes going on. That's why it's important to take refresher classes periodically to keep up to date with the changes. It's also a good idea to subscribe to different periodicals, different information sources that can help us keep up to date, keep us aware of changes. You can subscribe to an OSHA information sheet, an OSHA newsletter, where they will periodically email you out the latest news in OSHA. That's an excellent one to subscribe to. All right, moving on. Just for fun. Oh wait, that's the same one I looked at before. Yeah, never mind. Thought that might be a paint thinner link, but that is aerosol paints also. The work process, and I'm running out of time here. I'm taking up too much time. I'm having too much fun talking about this, so I will speed it up. I just want to give you a kind of an overview of this process that we might go through to do this environmental hazard evaluation process. The work plan, the process flow, the process description. This is a description of the operation, and it can be really detailed, and it can have diagrams and so on and so forth. I've just got a very simple description here: painter suit up, designated appropriate PPE, enter spray area, ventilation system operating before the first spray for X minutes, and for X minutes after the completion of spray. There's going to be a lot more to it than that. In my real process description, I'm going to show more detail with diagrams. There may be checklists involved. And now this process description that we're talking about, this would only be for that painting operation in our example. There would need, ideally, to be additional planning, additional hazard analyses, additional work plans for other hazards that are associated or that may be associated with our ship building operations. Preliminary field survey. Assess the work area and the setup of all equipment in the paint area before initial operations. Things we might want to look at. Is the lighting, illumination, is it sufficient? There are OSHA requirements for lighting levels in work areas. If our work area is not properly illuminated, companies could receive a citation. But more importantly, OSHA is never the most important thing. The reason you want good illumination is so nobody gets hurt. You want good illumination so nobody gets hurt, and also so the quality of your work is not diminished because of poor visibility, poor lighting. I mean, that's lighting, illumination. That's a no-brainer. You got to have it lit up properly for the work to get done properly and to get done safely. This field survey period might be a good time to bring in a consultant if you're going through this process. Again, that's just something to consider. It might be a time where you would test your ventilation system. If it's a painting operation, you're going to have ventilation systems more than likely. It's a good time to test out that system. And there's a whole lecture on the ventilation system testing procedures. There's a whole lot of things that we would need to do and ways that we could do it to test that ventilation system. One thing that we might want to do along with this is take measures of the temperature in the work area, and we could assess the air volume being moved. We could do a smoke test to see how the air is moving, and so on. But again, that could be a whole lecture, almost a whole class all by itself. Also, we would want to make sure that we, at this stage, during this step, this would be where we would want to make sure we have all the monitoring and sampling equipment that we would need to monitor exposure levels, concentrations, and exposure levels in the workplace. Now, one thing I want to mention here, and this is not really that important, but it's just one of my pet peeves. I hate jargon. I hate over technical terms. Keep it simple. Keep it on a level where anybody can communicate with you. We're not special because I think we try to make ourselves special sometimes with all our fancy words. But when you see the word survey like this, it's a jargon word. It's really, they're talking about an inspection process. It's not like a survey that where you fill out a questionnaire. But it's commonly used, and I would never say anything to anybody about it if they were using this in a presentation or wherever it might be used. It's not worth debating anyone over. But it's just when they're talking about a survey, normally it's some type of inspection, some type of monitoring that's going on. And speaking of monitoring and sampling, during the operation, we're going to be monitoring for a lot of different variables. The concentration of toxins in the air, the temperatures, the LEL level are going to be monitored. We probably won't have any substances that would require more of a sampling procedure. Most of our monitoring could be completed with what we call direct reading instruments, and I'll show you some pictures of some of those here on the next slide. But I don't want to completely discount the possibility that we would need to do some grab sampling or some other type of sampling procedures. But most of what we would be monitoring for can be done with direct reading instruments. And let me just mention, direct reading instrument, that gives us an immediate reading of what our concentrations are. With sampling, you take a sample of the air, you send it to a lab, and they tell you what's in your air. or you pump air through a filter media. After the sampling is done, after you've pumped so much air through that filter media, then you send the filter media to the laboratory, and a lab technician will count the number of silica particles in the filter media, or asbestos fibers, or whatever it is we're sampling for. With direct reading, you have immediate feedback. With sampling processes, you have to wait. You don't have immediate feedback like you do with direct reading instruments. And these are both, this is the topic we go into great detail with in the second class. Not so much in this class, but in the second class we spend a lot of time talking about the different procedures, equipment that's available. We do some hands-on stuff, ideally, or we used to. See how that goes with online. But much more information to come in the second industrial hygiene class. And the key question that we're answering here with this monitoring process, are workers exposed above the exposure limits? What is the concentration? Are workers below, at, or above the exposure limits? And we could be using the PEL as a standard or the TLV. The question we're asking, simplified even further, is it safe for workers? That's why we do this, the monitoring and the sampling. And here are some pictures of direct reading instruments. Over here on the right, this personal monitoring device, really common, a lot of industries. They're usually 3 or 4 gas, multi-gas monitors. They're going to test oxygen level, H2S, the LEL, and carbon monoxide. And that covers a lot of what you need covered in many work environments. And one of the things that I noticed in the construction industry, my biggest concern wasn't carbon monoxide or H2S, it was oxygen deficiency in confined spaces. Oxygen deficiency. Now, if you get a worker inside of a confined space with poor ventilation, they can use up the oxygen pretty quickly, and that little device will start beeping, showing low oxygen concentration and unsafe oxygen concentration. And low oxygen is just as dangerous as high H2S or high carbon monoxide. I think it's at about 6% oxygen we die. and we don't even, it doesn't even have to get that low to have really adverse effects. Once oxygen starts to get below that 20% range where we like to see it, that 20% area where we like to see it, once it starts getting below especially 19%, that's when you can start seeing some effects. And there are other variables involved in that. The health of the workers who are out of shape are going to be more impacted by workers who are physically fit and so on. But you'll probably end up working with devices like this. Now the device here, this is like a $20,000 device. You can put different chips in it. It can be programmed differently, and you can test for up to 120 different contaminants. It's got the wand that you can use to hold right up against a pipe joint or inside of a piece of machinery to take a reading. But it will give you a direct feedback on whatever substance it is that you're looking at. Then we have an organic vapor analyzer over here. These are also very expensive. They also give you immediate feedback. Then in the lower left, let's not forget about the potential for heat-related illness. This would be a heat stress monitoring device. Instead of using the formulas to calculate the wet bulb globe temperature in the workplace, this device will do it for us, and it will provide us with a lot of other information as well. It takes into consideration the humidity, and the temperature in the work area. A lot of athletic teams will use devices like this. They'll have them set up in their practice facilities to make sure that it remains safe for the athletes. And you see these in workplaces as well. All right, last thing would be the operations survey. This is after everything is going, the work is in process. The operation is in process. One thing I would want to do, talk to the workers. Get their insight on how the process can be improved. Do they have any physical discomforts? Are they having any symptoms? Are they going home with a headache at night? Or just talk to them. We can learn so much about our operations and how we can improve those operations just by talking to the workers. If we do notice any deficiencies from our monitoring or from our other or from other observations that are made or from interviewing workers, we want to try to correct those deficiencies as quickly as possible. All right, hopefully you're getting a pretty good idea of what industrial hygiene is all about. Again, it's about in the work environment, chemicals, work processes that can have harmful effects on the workers. This evaluation process, hopefully walking you through this and talking a little bit about this, makes it a little more clear in your mind what industrial hygiene is all about. If you have any questions about anything, let me know. This is the last video lecture in this unit, but there's a lot of great information in Chapter 1. I don't really need to do as much in the video lectures for this unit because there is such great information. You could probably have a pretty good understanding of industrial hygiene just from the reading without listening to me. But I'm probably more fun to listen to than it is to read. So just kidding, you probably hate listening to me. But anyhow, let me know if you have any questions. In the next unit, we're going to continue. We're going to dive a little deeper into industrial hygiene. We're going to talk about industrial toxicology, which I find real interesting. But I find all this stuff interesting, so that may not be a good measure of the next topic. So I will shut up. I will see you in the next video.